So, when we last looked at things, we were looking at this Targ board, and we have to check the ROMs and then replace the bipolar prom with the with a new one. We're going to use my kit to put a 27512 in there, and then we're going to try to hook it up to this monitor over here and see if it will work. So there's the board that we were looking at, and it's already hooked up to the Fluke. So let's go ahead now and pop these values in here, and I already printed out the ROM addresses and what the checksum should be, so let's go ahead and pop them in there. So the first one is 1800 to 1FFF, and it's going to be B5DA. See what it says. Looks good. Alright, let's go to the next one. 2000 to 27FF, D4AC. Looks good. Let's go to the next one. 2800 to 2FFF. That should be ED8C. Okay, that's good. 3 down, 2 more to go. Range 3000 to 37FF, 61F0. Looks good. And the last one. That's 3800 to 3FFF and B8CD. Good. So all these ROMs look like they're good. And the ROMs again are right here. I'm going to actually go ahead and take this off. ROMs are right here. And you might be asking, if you've watched my videos before, you've probably already known how I do this, but how did I get these ROM values? I used the MAME drivers code to get the addresses of the ROMs, and then I just went to the MAME ROMs, downloaded them, and unzipped them, and then ran each of these through Hamster's ROM ident website, and it prints out the Fluke signature for them. So now we have to replace the bipolar RAMs. It's a 82S 123. And we can remove this video sound card because the sound's not necessary for the game to work. And that's going to have to go in here. And again, we're going to replace this with we're going to program. I'm going to program a ROM and put in my adapter and put it right in that slot. So one of the other things I wanted to do is to test the 6502 CPU off the Targ. Normally I can tell if everything's working because a watchdog is not resetting, but since the Targ doesn't have a watchdog, and I don't even really know about the video situation because I've never messed with a Targ without the CGA monitor. So I figured it might as well just be a good idea, since I know the RAMs work and the ROMs work, to also test the CPU. So the way I'm going to do this is I have this Centipede board that I use to test all kinds of random components. It's got quick zip sockets for CPU, Pokey, 2114 RAMs, and I can also have, I don't have a zip socket, but I can put in 2101 RAMs in here in the sockets and test them. So I'm just going to put the CPU socket, or the CPU in the CPU socket, turn it on, see if it works. And if it does, I know the CPU works, so then I'll just put it in, and look at that, it does. So Centipede is playing fine. So that means the CPU for that Targ board is also fine. So we'll go ahead and put that in there. So we have checked the RAMs and the ROMs on this, and all the RAMs and the ROMs are good. And I have to figure out how it hooks up without if I can hook it up to something without the CGA card. But I thought, it would be a good idea to first just check out the signals. before I started messing around, and this is how it attaches to the CGA board. It attaches with this, and there's a little cable, I don't know where I put it. Here it is. So, then we'll attach to the CGA board. But I wanted to see if these signals are even good. So I got out the schematics. You see this pin has at pin 6 and 8 we should see H-sync and V-sync. Unfortunately, there is no V-sync or H-sync signal when I look at those pins on an oscilloscope. You can tell it's not going to work right now because there's no syncs. So that's not good. So went back in the schematics and look at where the syncs are generated. We find that the syncs are generated over here. So I started probing these things to see what's going on. I checked all the outputs on 2D, the counter, and they all look good. So then I just started going out these guys. And one of the first things I noticed is that this 04 here doesn't seem to be working correctly. So let's just probe all the outputs on the 04 and I will tell you what I'm probing and what signals we have. Okay. So, hopefully you can see that. On this 04, we should have pin 1 should be an input. And there should be a signal, yep. Pin 2 should be the opposite of that signal. Pin 3 is a signal. Pin 4 should be the opposite of that signal. So we have outputs on pin 6. 1, 2, 3, 4, 5, 6. Oh, that output is dead. Alright. Its input is 5. Let's see what input 5 is. Alright, that is clearly an input signal, and that's good. But there's no output signal. It should be the reverse. So, I'm gonna go ahead. This is a Signetics chip, and they seem to be always bad. They are one of the most commonly bad chips I see. That and some Fujitsu's. So we'll put this in, we'll pull that out, put another chip in here. This jumper wire, I don't know what the deal with this resistor is, why it was there. There's a cut on the board. I don't know if this was factory. I guess you can't see that or not. But we went ahead and replaced this chip right here. And now let's see if we have anything on pin 6. So 1, 2, 3, 4, 5, 6, and there we go, which is the opposite of the input. That looks good. We have pin 1, pin 2, pin 3, pin 4, pin 5, pin 6. That's good. So now let's see where H-sync is coming from. And H-sync seems to be coming from... Well, actually, let's make sure we have outputs on all of these pins. So we have pin 6. We did pin 6 already. 6, that's got an output. We have pin 4. That's got an output. We have pin 2 as an output. Anyway, let's see if we got anything on that, on our H-syncs and all that now. 1, 2. And it was 6 and 8 on this chip here. Okay, at 16B. Let's see. I'm going to go ahead and probe on pins 6 and 8. 1, 2, 3, 4, 5, 6. Nothing still. 7, 8. Nothing still. Alright, so somewhere along the line something is still broken. So we found one chip that's bad and we replaced it. What else could be wrong? Well, let's go see where where these syncs are generated from. So pin 6 was either H-sync or V-sync. H-sync. So let's see where H-sync is generated. And it looks like H-sync is generated from 2E, which is output pin looks like 7. So let's look at 2E, output pin 7, and see what we got on the screen here. Alright, so 2E, pin 7 is 1, 2, 3, 4, 5, 6, 7. Okay, we have no output on there. And 9 should be the opposite of 7. So let's see if we have an output on 9. 8, 9. Okay, nothing there either. All right. So, well, it could be that chip, or it could be something driving that chip. Let's see what drives that chip. Let's see what's driving that chip. Well, we have a bunch of things. Where shall we start? Well, let's look at the inputs on this chip. Looks like 11, 13, and 12. 2E. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No input on 11. No input on 12. No input on 13. So, it's probably not this chip that's bad, it's probably whatever's driving it. Alright, well, let's go to, what's driving the clock on that? That's going to be 12, pin 12 and 04 at 1D. Alright, so we'll go to 1D. Oh, no, there's another chip. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's dead. Its input is 13, and it is not dead. So we go ahead and pull that chip. Alright, the chip we're looking at right here. Sorry, right here, 1D. 12 is an output. It has no output, but its input is valid. So I'm going to go ahead and pull it out and replace it and see what happens. So we pulled out that chip, the Schematics 7404. Yeah. And put in our tester, and we get error. So we'll go ahead and just replace that. So we replaced that chip for here. I'm sorry. For here. 1D. And let's see what happens. Let's power it back up and see what happens. And it should be giving a signal on pin 13 as well as 12. So let's power it on. And pin 12, 13 was the input, pin 12 was the output. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we have a signal. Alright, good. And let's see if we have now. Okay, now I have a signal. 2, 3, 4, 5, 6, 7, 8. And now I have a somewhat of an H-sync signal. It's looking weird. I don't know what is wrong with that. Am I not? Signal doesn't look right, but that's probably, I probably have something wrong with my oscilloscope here.
So this signal is definitely not right. I think there's something that's not my oscilloscope. I think there's something wrong with the chip.
Okay, so I replaced that chip and it started flipping out when I tried to measure it. I don't know, I put another one in. I don't know if I burned, I actually turned my, the other day I turned my soldering iron up way higher because well, never mind. But it's possible that it was a bad chip. It's possible I damaged the chip when I was soldering it. I don't know. It's we went ahead, I put a new one in. I was getting really messed up signals. But now our signals are good. Okay, so there's my CPU clock, and I went ahead and tried pin 6 on the output. That's H-sync, and about 15, and then pin 8. We have about 60 hertz, so that's about right. 15 kilohertz and 60 hertz, right? So hopefully that is good. Now I have to get a video signal and see if I can actually get a good signal.
So there'll probably be one more episode of this where I have to find a video card. I know I have one somewhere for the Targ board, and then finally test it out. And we'll do that in the next episode.